Hi. Pierre from the science teacher. So I welcome you to today's lesson. And in this activity, we're going to do just something very simple. We are going to show that impulse is equal to change in momentum. All right. So the first thing we're going to do is to define what momentum is and what impulse is. Let's begin with impulse. So impulse, in simple definition, is simply the integral of force over a given time. All right. In some words, we say it's a product of force. I mean, it's a product of force and time. This is impulse. Okay. All right. So when we say change in momentum, we actually mean mass multiplied by the final velocity minus the initial velocity, right? This is what we mean when we say change or delta momentum. This is what we mean, right? So we are going to show that this is actually equal to this because this is what we are calling change in momentum. All right, so what we are going to end up with is this velocity, equation of motion that is going to show that actually momentum and momentum, changing momentum and impulse can be equated or actually equivalent. So let's go. So momentum, we said, is the integral of force, right? And what? It's the integral of force over a given time. And impulse, we said this is the product of mass and velocity, right? But we're talking about what? We're talking about changing momentum. So which means this, remember what we did here, okay? So if we had to rewrite this properly, just from the word go, we would say the impulse, which is force times time, is equal to m v2 minus v1. This means momentum, changing momentum is equal to impulse, this being impulse and this being change in momentum. So the other thing that we know here is that we know from the Newton's second law of motion that this force is actually mass times acceleration, right? The second law of motion, Newton's second law of motion, also known as the law of inertia. So we're multiplying it a time, all right, and still equating it to mass final velocity minus initial velocity or change in momentum. So here we can have this mass and this mass cancelled. So what do we remain with? We remain with at, acceleration times time, and on the other side we remain with the change in velocity. So let's write what we remain with this side. So saying we're remaining with a times t is equal to v. Can even just get rid of the brackets. Let me use the sign. So say a times t is equal to v2 minus v1. So this is our final equation. This is the equation of motion that shows that momentum, no, impulse, is equal to change in momentum. So this is the equation that we've been looking for. This equation shows that or proves that impulse here is equal to change in momentum. So this is how it can be shown. All right. It's been just the science teacher. Let's learn together.